Jai Hind to all. Myself Dr. Neelesh Kumar Gupta. I am working as a professor at Ajay Kumar Garg Engineering College, Ghaziabad. And I am working in Department of Electronics and Communication Engineering. So today I will give a lecture for a subject of digital signal processing. Its AKTU code is KEC 503. And it's my first lecture. That title is IIR filter realization. How we realize the structure in IIR digital filter. That I will tell you in this lecture. Okay. So, firstly, here we will see digital filter realization. So, as we know that there are two types of digital filter, IIR and FIR. IIR means what? Infinite duration impulse response digital system या filter. Okay. So, and FIR means finite duration impulse response digital filter. So, we will see here the realization of IIR digital filter, and in this lecture I will focus on realization of IIR digital. So, at first you should know what is the meaning of IIR digital filter. IIR digital filter means what? Whose impulse response h of n lies or exists for infinite duration. It means h of n is equal to a to the power n into u of n when n greater than or equal to 0. Otherwise, it will be 0. Okay, this one. So, if impulse response is of this type, then our filter will be IIR. If our impulse response h of n, it is equal to, let's k for our filter length or n, it lies between the 0 to m minus 1. Otherwise, it will be 0. Okay. So, here our h of n lies for finite duration, where capital M is what? Where capital M is called length of our filter, length of FIR filter. Okay. So, in this way we can identify IIR and FIR, because there are two types of digital filter. First is IIR, that is infinite duration impulse response digital filter. Second is FIR, finite duration impulse response digital filter. But in this lecture, I will concentrate on IIR digital filter realization. Realization means what? To make the structure for particular filter. Let's IIR. How you make the structure, how you realize the IIR digital filter, whose impulse response lies for infinite duration. That's why we are calling this is IIR digital filter. Okay. Next. So, some basic building blocks in realization that you need whenever you want to realize your IIR digital filter, some basic building blocks, some component that you need it. Okay. So, like an adder. Adder means which adds the signals. The multiplier, it means you can multiply by the signal. Okay. And third is this is the new for you, that is unit delay. It means Z inverse or storage elements. Okay. So, these three main components that you need whenever you want to realize your IIR digital filter. Okay. So, we will see how it is possible. Like if we are using the adder here. So, here x1n is coming, from here x2n is coming, then here x1n plus x2n. It means by the adder, both the signals are added through the adder. So, first block is there. Second block is what? It shows the multiplier. So, if you are giving the signal x of n here and you are using the multiplier what? By a. So, signal will be a into x. So, your signal is x of n initially, but through the multiply, your signal now becomes a into x of. So, this is our multiplier. Now, third is what I told you, unit delay element. Unit delay element means what? Ki x of n if you are giving here, so unit delay element or storage element, it is represented by z to the power minus 1. It produce a signal that will be delayed by 1 sample. So, unit delay element, it means it delays your signal by 1 sample at a time. If you need xn minus 2, so you need what? 2 unit delay elements. At a time, 1 unit delay element only delays your signal by 1 sample. This you have to keep in your mind. Okay. Next. Now, we will see here regarding our IIR filters. So, IIR digital filters. First, what? The output of the system depends upon the infinite number of impulse response values. What I told you? If your h of n is of infinite duration. So, that's I am writing here. What? It depends upon infinite number of impulse response values like h of n. Okay. Next, it involves the feedback. Feedback means if your output again goes to input. So, in IIR, feedback will be there. Now, it contains both poles and zeros. It means if you write the transfer function or system function or gain of the IIR filter, so it contains numerator and denominator containing the zeros and poles. Next, it can be realized using the recursive realization technique. Recursive and non-recursive, that also you should know. Recursive means it's if your output depends upon the present value of input, past value of input and past value of output signal, then it will be recursive system. Similarly, non-recursive means simple causal system. Simple causal means what? If your output depends upon present value of input signal and past value of input, that is non-recursive. So, you can say that any causal LTI system further classified into 2 categories. First is what? Recursive, and second is non-recursive. Non-recursive as usual as causal. What? Whenever your output depends upon the present value of input and past value of input. But recursive means whenever your output depends upon present value of input, past value of input and past value of output, like a flip-flop. That's why we say what? It involves the feedback. So, that difference you should know between the recursive and non-recursive, because it will be helpful to you whenever you realize the IIR digital filter. Okay. Next, these are the different methods of IIR filter realization. Okay. So, first method, that is direct form 1 and direct form 2 realization, then cascade form, then parallel form, then ladder. Okay. So, these are the different forms of realization of IIR digital filter. But this direct form 1 and direct form 2, these are the 2 basic methods of IIR filter realization. These are the very basic methods. Okay. If you know the direct form 1 and direct form 2 realization, then you can easily realize using the cascade, parallel and ladder realization. Okay. So, these are the 2 basic realization. Okay. After that, you can realize by the different another form of realization. And now we come on IIR realization. Okay. So, this is the standard form of IIR filter realization. Okay. Whenever any filter is given to you, then always its transfer function or system function is defined to you, h of z. In discrete time system, everything you can simplify and solve by using only and only z transform. So, h of z is what? H of z is called your system function or transfer function. it is given to you generally. Okay, transfer function. So h of z, that is called system function or transfer function of the digital filter. It is what? It is what? This is yz by xz. It means if you have to define your system function or transfer function, so you can define that what? It is the ratio of z transform of output signal to the z transform of input signal. And this is the standard equation of IIR digital filter. So, it contains numerator and denominator. Okay. So, it is what? From k0 to m, bk into z to the power minus k. bk shows the some multipliers, coefficients, forward coefficient you can say. And upon 1 plus from k1 to n, ak z to the power minus k. So, 0 to k, it means it shows the present and past value of input signal. And if I am going 1 to n, ak into z to the power minus of k, so it shows the what? Past value of output signal. So, always in case of IIR, whenever h of z is given to you, then numerator part always shows the non-recursive term. Non-recursive term means कि output depends upon the present value of input and past value. And denominator part always shows the recursive term. This is not. Recursive means what? Present value of input, past value of input and past value of output. You have to concentrate on past value of output. That's why it will go from 1 to n. Because past value of output start from 1. If first output you are getting, then you can take the past value of that first output. So, always remember this. What? In h of z, zeros and poles both will be there. Zeros or numerator part always shows the non-recursive term and poles always shows the recursive term in IIR digital filter. Now, IIR realization. So, in this I am showing this mathematical standard expression for IIR digital filter. So, about this I am writing in this PPT. What I am writing? The block diagram representation can be drawn directly for the direct form realization. The multipliers in the feed forward path are numerator coefficients. So, these multipliers like bk. So, it starts from b0, b1, b2, b3 up to the b of capital M. These are the feed forward path, or you can say these are the numerator coefficients shows for the non-recursive term. Okay. Similarly, multipliers in feedback path are negative of the denominator coefficients. So, here you can see this multipliers. This should be negative. Why? Because multiplier in denominator shows the recursive path. Recursive means you are taking the past value of output. If you are taking the past value of output, okay, so that should be negative because you are coming from output to input. If you are coming from output to input, this one. So, you are going in opposite direction, okay. That's why these are the negative coefficients available in denominator part shows the recursive. Since the multiplier coefficient in structure are exactly the coefficient of the transfer function and they are called direct form structures, okay. Now, at first we come on direct form 1. Okay, what is the meaning of direct form 1? So, whenever you want to realize direct form 1 structure, okay, so firstly you have to realize non-recursively and after that you have to realize recursive, because in IIR numerator and denominator both are present. The if hz is given to you, okay, that is nz by dz. So always our this part shows the non-recursive term and this part shows the recursive term. Always it will be. Okay. So in direct form 1, firstly you have to realize your H of Z, your structure of IIR digital filter non-recursively. And second, you have to realize recursive. So system function will be divided into two parts connected in cascade. Cascade means the output of first stage will go to the input of second stage. Similarly, in output of next stage will go to the input of the next stage. Okay. So then what? Non-recursively. At first you have to realize non-recursively containing the zeros. Then you have to realize your structure what? Recursively, that containing the poles. Okay, so this will be the structure. If you realize by using direct form 1, so this will be the block diagram. Okay, so here you are giving the input. At first, your system, you have to realize non-recursive part, non-recursively, and second, you have to realize recursively. This will be. Okay. So at first, you have to realize the numerator part of H of Z because that shows the non-recursive term. After that, you have to realize what part? Denominator part of your H of Z. This W of N, we are supposing here intermediate output for this and intermediate input for this system. So in direct form 1, always it will be clear. At first, you have to realize the zeros or non-recursive term, and after that, you have to realize recursive term. So finally, your structure will be direct form 1 structure. So in direct form 1, what will happen? Firstly, we have to realize non-recursive, then recursive. So non-recursive means what? Present value of input and past value of input. So input ki past value, it means what? This one. So in this way, you can draw. Recursive means what? Present value of input, past value of input, and past value of output. So in this way. So this shows the non-recursive and this shows the recursive. This is your input and this will be your final output. Okay. So here you are realizing the zeros. Here you are realizing the poles. Similarly, this will be structure further will be continued if expression will be there in numerator and denominator part of H of Z. So in this way, we can realize IIR digital filter by direct form structure, in which at first you have to realize non-recursive term and after that you have to realize recursive term. It means as in H of Z, at first this. So at first you have to realize what? This, and after that you have to realize this one. So that structure will be what? Direct form 1 form of digital filter realization. So this will be the final structure. If you draw this, I told you in rough way, okay, what will happen if you draw, if you want to draw, if you want to realize, if you want to make realization using the direct form 1. So this will be your final structure. Here you can see like my previous PPT, what? This is our what? Present value of input and past value input. First past value of input, past value of input is. So this part shows the all non-recursive terms, or we are realizing first what? Our zeros of H of Z. Then we are taking the what? Past value of output signal from here, this again, this. And this term shows the recursive part. So this is our direct form 1 IIR filter realization, in which firstly we have to realize non-recursively our term. After that we have to realize recursively our terms. Okay. So I think it will be clear to everybody how you realize the structure. Let's see some examples based upon the direct form 1 filter realization. Okay. Now this is the question. Okay. How you realize, how you make the structure, that also you should know. Okay. So in this example, what is the question? Develop a direct form 1 realization of difference equation. So here we are using the word of difference equation. In analog, we use the word of differential equation, but here difference equation we are using, okay, because we are taking all the signals in discrete form. So in discrete form, that differential equation becomes here difference equation. Okay. So here y of n is equal to b0 xn, b1 xn minus 1, b2 xn minus 3, b3 xn minus a1 yn minus 1 minus a2 yn minus 2 minus a3 yn minus 3. Okay. So now you have to realize this using the direct form 1. It is very, very easy, so easy. Generally h of z is given to you. Okay. Otherwise, difference equation is given to you. You have to convert this difference equation into h of z. H of z is what? H of z is equal to yz upon xz. So simply you have to take its z transform. So if you take the z transform both the side of this equation, then what you will get? Yn ka z transform y of n is what? Y of z. b0 xn ka, it will be b0 x of z plus b1 z to the power minus 1 into xz plus b2 z to the power minus 2 into xz. Here what? We are applying the time shifting property in z transform. Okay, simply we are doing here plus b3 z to the power minus 3 into x of z. Now minus a1 z to the power minus 1 y of z minus a2 z to the power minus 2 into y of z minus a3 z to the power minus 3 into y of z. So in this way, simply you can take the z transform of given difference equation to make it in the form of h of z. What is h of z? H of z is equal to yz upon x. Now you have to take yz and xz terms in both the sides. Okay. Separately you have to separate the terms of yz and xz. So if you separate the terms of yz, then it will be y of z, it will be 1, okay, 1 plus a1 z minus 1 plus a2 z to the power minus 2 plus a3 z to the power minus 3 is equal to what? xz b0 plus b1 z minus 1 b2 z minus 2 plus b3 z minus 3. So I am separating here the terms of yz and xz. What I want to get? H of z. That is the ratio of yz by xz. So in the last, what? I am separating the terms of yz and xz, then I will get h of z is equal to this one. Okay, this one. So here our numerator term is this. It contains the zeros and shows the non-recursive part. Our denominator term, it contains the poles here and shows the recursive part. Okay. So in this h of z, you will have non-recursive and recursive term. And from this expression, you can make a structure using the direct form 1 form for IIR digital filter. So simply you can draw a structure in this way. In this, at first what? In direct form 1 what? Firstly, you have to realize your h of z non-recursively, then recursive. So firstly, you have to realize numerator part zeros, Then you have to realize denominator part, it means poles, okay, and structure will be in this type. So, firstly this term contain the B0, B1, B2, B3, oh, these coefficients non-recursive. Okay, in recursive form what coefficient you will get? A1, because this here we are taking the feedback. So, our coefficient will be in opposite sign. If plus A1 coefficient is here, so in the block diagram, in the realization structure, it will be minus A1. If here it was minus A1, then in structure will be plus A1. Okay. Why? Because we are taking the feedback here. We are taking the output to input again here. Okay. That's why we are taking this one. Okay. So, this is our non-recursive and this is our recursive. So, in this way, we can realize our IIR digital filter structure using direct form 1. Okay. Now, another example we can say here, again difference equation is given to you and you have to realize using the direct form 1 structure. At first, again take the Z transform. If you take the Z transform, it will be y of z is equal to 0.5 Z inverse y of z minus 0.76 z to the power minus 2 into y of z plus 0.63 z to the power minus 3 y of z plus x of z plus 0.875 z to the power minus 1 into x of z. Okay. Now, separating the terms of xz and yz. So, what will happen? Yz, if I am separating, then 1 minus 0.5 z inverse plus 0.76 z to minus 2 minus 0.63 z to power minus 3 is equal to x of z 1 plus 0.875 z to the power what? Minus 1. So, this will be the expression. Now, what you want? You want h of z, that is the ratio of yz and xz. So, yz upon xz is equal to, you will get the expression and this will be our final structure here. This first term what? In direct form 1, which is direct form 1. So, firstly you have to realize numerator part. Okay. So, here numerator part what? It will be numerator part. Okay. So, these coefficients will be there. So, you can see here. So, 1 and 0.8. So, this is our non-recursive part. Second, it will be recursive part. Recursive means what? You have to take poles. So, poles value is what here? This. Okay. So, if you transfer this, okay, so it will be what? If it is minus 0.5, so in the diagram it will be plus 0.5. If it is 0.76 plus, so here there will be, it will be minus 0.76. So, in this way you can realize your structure. So, this is our recursive. So, I hope that you all understand the direct form 1 realization. How you make the structure using the direct form 1 method in IIR digital filter. Next, we come on what? Direct form 2. So, in direct form 2, this process is reverse. Firstly, we have to realize recursively, then non-recursively. So, since we are dealing with here linear system, so order of these parts, it means recursive and non-recursive, can be interchanged. If you interchange this, then that structure, that direct form 1 structure converts into the direct form 2 realization. Here firstly what? You have to realize poles recursively, then zeros, what? Non-recursive. So, h of z you have to broken into product of h1z and h2z. h1z always shows the poles that would be realized recursively, and H2Z contains the 0, that would be realized using non-recursive. Okay. So, I think it will be clear to you. If you interchange the recursive and non-recursive part in realization of IIR digital filter, then simply direct form 1 converts into direct form 2 structure. Now, in this way, this is our sample block diagram. Okay. Firstly, you have to realize the poles in recursive form, and secondly, you have to realize the zeros in non-recursive. Then you will have direct form 2 structure. And now this will be the form of direct form 2 structure. Firstly, what? Here you can see these are the recursive structures. Secondly, it will be non-recursive. Okay, this. So, this is our direct form 2 structure. Only you are interchanging zeros and poles. You are interchanging your blocks. In direct form 1, this section was here and this section was here. Okay. In direct form 2, firstly you have to realize your poles recursively. After that, you have to realize your zeros non-recursive. Then it becomes simple direct form 2 structure. Here one interesting thing that you will find in this diagram. If you combine this, just a minute, if you combine this delay element by single one, similarly if you combine this delay element by single one, similarly this by single one, so your delay elements are just reduced to half, but single delay element, it will work for recursive term and single delay element, it works for recursive and non. So your number of components are reduced here in this way. Okay. So you are using only single delay element, it will work for this, it will produce the y of n minus 1 for here x n minus 1. So combining the two delay elements into single one here, okay, and direct form 2 structure further you can make. So this is the advantages of direct form 2 structure, that the number of delay elements in comparison to direct form 1 are reduced to just half. If in direct form 1 for particular system function you needed 6 delay elements, so in direct form 2 only you need 3 elements. So this is the biggest and very important advantages of direct form 2 structure. In this way you can also draw in terms of signal flow graph. Now canonic and non-canonic structure, what is this? So if the number of delays in realization block diagram is equal to order of difference equation, then it will be canonic. If it is not equal, then it will be non-canonic. So number of delay elements, it means z to the power minus 1 element. These are equal to order of difference equation or order of our transfer function h of z or system function of digital code, then it will be canonic, otherwise it will be non. Generally the direct form 2 structure is canonic and direct form 1 structure is non-canonic. That you have to keep in your mind. And further I will tell you how we can call here that direct form 2 will be canonic structure. Okay. Now this is direct form 1 structure. So you can see in direct form 1 structure here, this shows the non-recursive terms and this shows the recursive term. Clearly you can see here. So in this direct form 1 structure, this is non-canonic. Why? Because it employs the 6 delays, 6 delay elements, 1, 2, 3, 4, 5, 6 to realize the third order transfer function. It means h of z is of third order here only, but you are using the 6 delay elements. So, order of difference equation, order of transfer function is not equal to number of delay element. So, it will be non-canonic structure. So, direct form 1 structure always will be the non-canonic. Why? Because in this the number of delay elements is not equal to order of difference equation or order of transfer function for particular digital IIR filter. Now, draw the direct form 2 for this h of z that is given in the question. So, in the question, in the examples, either difference equation is given to you. So, from that difference equation, you have to make at first h of z, then you have to realize your digital filter. Or h of z is directly given to you and you can realize your structure. So, direct form 2. So, the numerator part always shows the recursive term. This shows always the, this is non-recursive term. This will be the recursive term. Okay. So, you can realize easily here, okay, in this diagram. By this diagram, you can realize easily here. So, in direct form 2, what I told you that we can combine the two delay element into single one. Then your input output will not be disturbed. So, here you needed what? 3 delay elements only, and your order of equation is what? 3. So, here your order of equation or order of transfer function is equal to number of delay elements. The order of transfer equation is 3 and number of delay also using in realization is 3. So, it will be canonic structure. So, always your direct form 2 structure will be the canonic. This facility, this property is possible only in direct form 2. Okay. Now, this is the advantage of direct form 2. So, direct form 2 realization requires only the larger of m or n storage elements. When we compare to direct form 1 realization, then minimum number of storage elements will be needed. So, it will be canonic structure. So, in direct form 2, what? You are able to reduce the delay elements, storage elements. Now, this will be our final structure. Okay. Direct form 2. So, this is what? It shows our recursive part, this shows the non-recursive. Now, you can combine these two delay elements into single one, these two into single one, these two into single one. Similarly here. So, almost you are reduced your delay elements to the half values. Okay. Here. So, this final structure you will get using the direct form 2 structure. So, these direct form 1 and direct form 2, these are the two basic realization methods that you have to use at the time of realization of IIR digital filter. Next is cascade realization. Cascade means what? Simply, okay. What? So, two another important form, cascade and parallel. Ladder form also will be there, but I will tell you this in this lecture. So, in cascade realization, our transfer function, it will be splitted into product of transfer function. So, h of z I am splitting here into productive form. So, h of z is equal to h1z into h2z into h3z and so on. Okay. And how it is possible? By factorization. So, factoring the transfer function h of z, you have to split your h of z into some productive small transfer functions. And you can realize individually these small structures, okay, using the direct form 1 or direct form 2 as per your convenience. Okay. Now, each individual factor is realized again small direct form 2 or 1 structure and then cascaded. So, here h of z you are splitting, okay. Now, you are realizing. So, generally we have to realize by using direct form 2. because in direct form 2, some facilities are there. Delay elements will be reduced. That's why we are using the direct form 2. So, this is our H1Z, this is our H2Z, this is H3Z, H4Z, etc. So, H of Z I am splitting here. So, it will be H1Z, H2Z, H3Z and so on. And individually this H1Z, H2Z, H3Z, we are realizing either using direct form 1 or direct form 2. So, in this structure we are using the direct form 2 realization, because basic structures are direct form 1 and direct form 2. Now, you have to split this H of Z into productive form by using factorization, then realization individually using the direct form structure. So, this is our cascade form, and in this way we can arrange these structures. Now, this is example, we can see in the example also for that. So, H of Z is given to you, okay. This is your H of Z. Now, what? You have to produce this H of Z into some productive terms in product form. So, how it is possible? You can make your expression into product form by using factorization, So, if you factorization this term, so it will be 1 plus Z minus 1, 1 plus Z minus 1, okay. So, 1 plus Z minus 1 whole square. Similarly, if you factor this term, it will be in this form. Now, we have to make the group. So, this group our H1Z and this group our H2Z, okay, this one, this H1Z and H2Z. Now, in direct form 1, this H1Z is realized. Firstly, we are realized in direct form 1, if we are realizing the direct form 1. So, firstly, it will be what? This is your non-recursive term, this is our recursive. This is our H1Z. In H2Z, this is our H2Z. This is non-recursive and this is recursive. So, from the simple expression, we can realize, we can make the structure using the direct form 1, direct form 2. So, at first, you have to convert this HZ into productive term. Similarly, you can realize using the direct form 2 here. So, in direct form 2, again factorization will be the same question is there, only your realization using the direct form 2. So, in direct form 2, this is our H1Z, this is our H2Z, and we can realize the digital system filter, IIR filter, using direct form 2. Again, some questions will be available, okay. You can solve. The H of Z you have to make into product terms, then you can realize. So, in this example again, you have to you have to make this H of Z into H1Z into H2Z into H3Z into H4Z, then realize your structure in this way. Next, the last I will tell you, that is parallel form realization. In parallel form, H of Z you have to prepare this H of Z into additive term, H1Z plus H2Z plus H3Z and so on. And to making the additive terms for this HZ, what you need? You need partial fraction of the expression, okay. And this parallel form is useful for high speed filtering application, okay. And generally parallel means what? You are doing the processing, you are applying your inputs or your analysis here simultaneously. Simultaneously you are doing, simultaneously you are applying all the inputs and you will get the output, okay. So, this is the parallel form. Each individual term realized as a small direct form 1 or direct form 2 subsystem and then parallel. So, in this question H of Z is given to you, you have to do the partial fraction for this system, okay. Okay. Then H of Z, You can prepare this one by using long division, and some rules and regulations are there. So, h of z you have to make into h1z plus h2z plus h3z and so on. And in this way, you can realize your structure. Okay. This is your h1z, this is your h2z, this is your h3z. Okay. This is your choice. Either you have to realize direct form 1 or direct form 2. Okay. Another example, you can see h of z is given to you, have to convert this h of z into additive form, h1z plus h2z, and you can realize your structure here. Okay. So, thank you very much. So, it's about my lecture. That's title was IIR filter realization. I hope it will be clear to everybody. Okay. If you have any query, so you can contact to my email ID, that is guptaneelesh@akgec.ac.in. Okay. Thank you very much.